Alright guys, welcome to this page of the notes, and again what we're doing is we're looking at those shortcuts, right? Those shortcuts that allow us to prove triangles are congruent without having to prove the six things that CP, right? Corresponding pairs of congruent triangles are congruent without having to prove those 6 things, right? These little shortcuts. So angle, side is the one that we're on right now. Let's go ahead and take a look at how this would work in these particular problems. Graphing is a big part of math, and we've done a lot of graphing so far this year. This will be no different. So here we go. Let's just take a look at what I've been given in my diagram, and then of course, information that I'm also given. What I tell you is that angle A and angle D are congruent. So let's put that in there. Okay. Well, here's angle A right there. Right there. Angle A and angle D. So I know that those two angles are congruent. Those arcs don't look so good. Let me fix them. There we go. Yeah, a little bit better. That one's still not very good. Yeah, okay, great. So I know I'm told that those two angles are congruent. And look at this. Guys, just based on the fact that these triangles are laid out on a coordinate plane, right? They're on a coordinate plane where the x-axis, right, is horizontal, the y-axis is vertical. That means that they're perpendicular. So what can you tell me about angle B and angle E? Just based on the fact it's laid out on a coordinate plane, you can tell me both of those angles are 90 degrees. I know that. I just look at it, right? That one's 90, that one's 90. So normally, if these triangles were not drawn on a coordinate plane, you couldn't say that, right? You can't just assume that angles that look like they're 90 degrees are 90 degrees. But in this case, right, I don't have to assume that. These triangles are laid out on a coordinate plane, and I know, right, since E is parallel to the x-axis, and this line is parallel to the y-axis, they're perpendicular, they must intersect at 90 degrees. They have to. They have to, because they're laid out on a coordinate plane. So I know A and D are congruent. I know B and E are congruent. So let me write that down too. Angle B is congruent to angle E. Well, we're off to a great start then. Angle, angle. Now all I need is a side, a non-included side. Well, here's the beauty of these coordinate planes and why I'm giving these to you. Count. Just count it out. Angle, angle, so I need this side. Angle, angle, I need this side. Well, what is the length of side BC? BC is equal to, count, 1, 2, 3 units. BC is equal to 3. Let's find out if EF is the same. EF is equal to, just count, 1, 2, 3 units. So here's what I now know. That side is congruent to that side, and angle, angle, side, angle, angle, side. I have enough. I know, thanks to the angle, angle, side theorem, these two triangles are congruent. Let's try another one. Exact same thing. I've laid out triangles for you on a coordinate plane. Here we go. I tell you that P and Z are congruent. Let's put that in my diagram so I don't forget. There's P right there. Boom. P is congruent to angle Z. Oh, that one right there. So angle P, angle Z. Awesome, we're all set. What else do I tell you? I then tell you, oh, right here, Q is congruent to X. Angle Q and angle X. Well, there's angle Q. Angle X, there it is. Fantastic. We're off to a great start then. Look, angle, angle, all I need is a non-included side. Angle, angle, all I need is a non-included side. Once again, I put it on a coordinate plane. Just count. There we go. If I can find side Q, oh, I have like OQ. Let's go QO or OQ. It doesn't really matter. OQ is equal to, let's count. 1, 2, 3, 4, 5, 6. It's equal to 7 units. Let's see. Corresponding side right here, XY. What's it equal to? Well, we counted out. 1, 2, 3, 4, 5, 6. Yeah, it's 7. So I know that that side is congruent to that side. Cuckoo, cuckoo, good enough. Angle, angle, side. Angle, angle, side. The angle, angle, side theorem works. Angle, angle, side theorem. Okay. Now, absolutely, those are nice and easy because you're just able to count the length of one of the non-included sides. Can I make it a little trickier? Yeah, you bet I can. Here we go. Got one more for you here. Slightly trickier. Here's what I tell you. A and D, congruent. Let's put that in. A, right there. And D, right there. Those are congruent. I also tell you that B and E, they're congruent. Well, there's B, and there's E. Fantastic. Now, here's what I need. I need a non-included side, but please notice that side BC is a diagonal. It doesn't run vertically or horizontally. I cannot just count. I can't just count the units, right? Because it's a diagonal line. Same thing here, AC. It's neither horizontal nor vertical. It's a diagonal. I cannot just count, right? Same thing over here, right? EF, DF. Neither of those are vertical or horizontal lines. Counting is out. So what do? Well, here's what we have to do. We have to do the distance formula. We have to do the distance formula. I can find the coordinates of any one of those points, plug those coordinates into the distance formula, check to make sure that those sides are congruent. So, here we go. I'll do this one in blue right here. There's B, there's C. I know that B is at, what is it at? It's at -5, +5, so -5, 5. I have C is at, what's it at? It's at -1, 2, -1, 2. Fantastic. Down here, there's E, there's F. E is at 1, 2. F is at 5, -1. Sorry, that looks like an S. Let me fix my 5. There we go. Okay, guys, all we're going to do, we just set up and run the distance formula twice. We'll do the distance formula for this line, distance formula for this line. If they come out to be the same answer, then I know that those non-included sides are congruent and angle, angle, side works. Fantastic. Distance formula. Please remember that the distance formula is this guy. It is x2 minus x1 squared plus y2 minus y1 squared, and we take the square root of all of that. That's my distance formula, so I'm just gonna plug and chug twice. Here we go. For my blue line, BC, right? This guy right here, BC, is going to be equal to, well, let's see here. Let's go x2, x1. So -5 minus a -1, -5 minus -1. Please, please, please be careful of your minus signs there. Please be very, very careful there. Then y2 minus y1, so that'd be 5 minus 2. So plus 5 minus 2, which I'll square. There we go. Then right over here, I have EF. Set this one up as well. Might as well, we're here. x2 minus x1. I'll do it the exact same way. x2, x1. So I'm going to have 1 minus 5, which I'll square, plus y2, y1, so 2 minus a -1, which I'll square, and take the square root. Okay, here we go. Let's do a little bit of math. So negative 5 minus a minus 1, add a line, change the sign. So negative 5 plus 1 minus 4. Plus 5 minus 2 would be 3, so that's going to be a 3 squared. Take the square root of all of it. Over here, 1 minus 5, that's going to be a negative 4. Ooh, I'm liking the way that this is turning out. Look, negative 4 squared, negative 4 squared. We're off to a great start. 2 minus a minus 1, add a line, change the sign, so it's 2 plus, sure enough, 3 squared. At this point, you really wouldn't have to go any further. Look, it's the exact same thing, but we'll keep going because, you know, we got this far. Why quit now? Negative 4 squared is 16. 3 squared is 9. Again, over here you get the exact same thing. Negative 4 squared is 16. 3 squared is 9. And then here's what we wind up with. 16 plus 9 is 25. So this turns out to be equal to the square root of 25, which is equal to 5. And no surprise, 16 plus 9, square root of 25, which is equal to 5. So sure enough, I get the same answer for both of them. What does that tell me? Well, that tells me that those guys are congruent. BC is congruent to EF, and now I've got it. Angle, angle, side, angle, angle, side. Guys, we did the distance formula way back in chapter 1. We have seen the distance formula a few times. Absolutely, I expect you to be able to work through the distance formula given 2 points to find the length of a line segment. Absolutely something I expect you to be able to do. And the angle, angle, side theorem is our winner. I know that these two triangles are congruent. Guys, thank you so much for joining me for this set of videos and taking a look at the angle, angle, side theorem. I had a great time. I'll see you next time.